This is in one of the op-amps circuit, which is used by IC chip of LM358. The simple circuit is actually called voltage follower, which has three useful features, such as input 3 volt, the output will be 3 volt without changed. Also, its input impedance is almost infinite. However, its output impedance can be as low as a couple of hundreds ohms without distorted circuit's function. This small board is just for a voltage follower, which does the functions described a second ago. That's a push switch for the power on and off. This is a LED indicator. The ends of the low pins are for the DC positive. The ends of the middle pins are for the DC negative, or ground. The top pin on the left side is for the output terminal. The top pin on the right side is for the input terminal. The board's positive has been connected to the battery's positive. The negative to the battery's negative already. There is another negative wire on the right side, for the convenience. The brown wire is for the input. The green wire is for the output. Push the switch, then a LED is on, and so is the power. Push the switch again, then a LED is off, and the power off. The mini signal generator's output has been hooked by a mini oscilloscope. That's sine wave output from the generator. The ground is the bracket here. Switch the power on, red LED indicator is on, then sine wave is showing on the mini oscilloscope. A 220 ohms resistor as a load will be connected to the output of the signal generator. Connecting now, this is the sine wave output terminal, which has been hooked by the scope's probe. The bracket here is the ground. It can be seen, the waveform has been changed, or distorted, not too bad on this experience. However, on the other occasion, which the waveform became a straight line. The reason for this is that mini signal generator has a limited loadability. In order to avoid this happen, a voltage follower showed earlier can be used here, in this instance. The voltage follower has been connected between the signal generator and scope. Its positive connected to the battery's positive, and so did negative. The LED indicator is on for the voltage follower. However, the signal generator's power is not on yet. The output of the signal generator has been connected to the input of the voltage follower. It's negative, or ground, connected to the scope's ground alligator. The output from the voltage follower connected to the scope's probe. Switch the signal generator's power on, and the red LED is on, then sine wave is showing on the scope. The same resistor will be connected between the output and ground of the voltage follower, instead of the signal generator's output, as did earlier. This is the output of the voltage follower, that's negative, or ground from the voltage follower. Sine wave is showing, the same as without a resistor connected, which means, no waveform distorted. Very good indeed. This result is using the voltage follower features. 1. Input and output has the same voltage value. 2. Its input impedance is almost infinite. 3. Its output impedance can be as low as practical, such as showed. Let us refresh. Using a voltage follower on an op-amp attached to the output of the mini signal generator will greatly increase the signal generator's loadability. Here is the voltage follower circuit's diagram. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.